Hi, hello friends, welcome to FunElectronics. What we are going to see in this video is how to generate square wave in Proteus by using Arduino board. So let's create new project. Select your path here and click next. Now we have to select the components. So let's select components. First we need the Arduino board. Double click this one. If you don't see this Arduino board in your Proteus, I will add the video link in the description. So click here and go through the video. So let's place the Arduino board. Here what we need is we have to observe the square wave. For that we need oscilloscope. So in here you can select the oscilloscope and click here. Place this one. So I am going to generate square wave from 9th pin. So let's connect the pin to pin A in the oscilloscope. So let's code for this. As you think, this code is look like blink function code. So here I have defined the pin 9 as output pin, and in the void setup I have set the pin mode as output. So in the white loop I have write the function here 100 millisecond the output pin should be high, it means 5 voltage, and another 100 millisecond the output voltage should be low. Likewise this code is work, so let's have this code. Let's the same folder you can say. Let's verify this code. There is no issue in this code, so let's extract that hex file. For that, click export compile widely. So hex file has been created. So let's upload the code to the Arduino. Here in square wave, here you have to select this hex file and click OK. So let's run this code. Here you can see square wave is generated. Here this is the time scale. So when we change this scale, you can see clearly. And this is the vertical scale. We can scale up vertically, and when we click this one shot, the waveform should be captured as fixed. So now this laser is used to measure the values in the positions. So here you can see 2.5 voltage, and here you can see minus 2.5 voltage, and in here you can see the period of this waveform is 200 milliseconds. The period of the waveform is defined by the delay in this Arduino code. Here you can see 100 milliseconds we maintain the voltage as high, and other 100 milliseconds we maintain the voltage as low. Likewise, the square waveform is generated, and if you want to change the frequency of this square waveform, you can change the delay time. Then the frequency of the square waveform will be changed. You know, one of the other important things is the duty. So when we change this code, when we change the Arduino code, we can change the duty cycle of the square waveform. Let's see how. On time as 300. So duty cycle is defined by T on duration divided by period of the square waveform. So here the duty ratio is 75%. So let's check. Let's write the code and export the text file. Stop the simulation and run again. Yep. When we click the auto, now we have to scale this waveform. Here you can see the on-time duration is high. So the duty cycle of this waveform is 75%. So when we change this to 250, what is the duty ratio of the square waveform? Comment your answers below in the comment section.